Hello.
Hey.
Bonjour. Yeah. So our talk is called App Architecture, which is coincidentally also the title of our new book. So do you want to tell me what the book is about?
Yeah, so we have been working on this since approximately a year together with Matt from Cocoa with Love. And we are covering a bunch of different architectural patterns in there. And for sure, not all patterns that are out there, but we've chosen a few of the more common patterns, like just MVC or MVVM, and then more experimental patterns, like the Elm architecture, or a pattern called MAVB, which is an experiment by Matt. And the point of the book is really not to sell you any of these and to tell you, well, this is the best one, or you should use this one, but it's really to compare them and to see what each architecture is trying to achieve, and what are the trade-offs, and how working with them is like.
Yeah, when we started talking about this book, we had a chat with Matt, and basically the idea was to write something like 1,000 different ways to write your iOS app, because we really believe that you can use almost any architecture as long as you consistently apply it. You can have really nice code, and just showing how these different architectures would work. And before writing the book, I believed that you could write clean code in almost every architecture. I wasn't completely sure, and now after writing it, I believe that even more. And for example, there was a reader who wrote in the other day saying, he read the MVC chapter, and he was surprised that he actually learned things. And this has been my experience with writing as well. When we started the MVC chapter, I thought, well, okay, it's MVC, it's boring. I mean, I know MVC, everybody knows MVC, it's all we've been doing. So what can you learn? And it turns out there's a lot to learn. So tonight, we're not going to talk about app architecture, but we're going to talk about model view controller. So, I see some people clapping in the front. Awesome. Okay, so we're going to talk about model view controller. And I think there are 3 problems with model view controller. The first problem is large view controllers. And the solution is to refactor them. We're not going to talk about large view controllers tonight. The second problem is view states and how to deal with that. And we'll talk about that. The third problem is observation. This is an often forgotten thing. And we'll also talk about this a little bit more.
And I think just to be fair to where this is all coming from, especially like specifically on iOS, how MVC is interpreted on iOS. If you think back when the iPhone first came out, or the first SDKs came out, the apps were extremely simple, and considerations of how do I communicate shared view state across a complex global app wasn't really at the forefront of things we have been doing back then. And so from the beginning, there hasn't been a really good story in the iOS SDK and the way Apple pitches Cocoa MVC in terms of these 2 things you mentioned, in terms of communicating view state and a consistent way to observe things you might be interested in.
Yeah, maybe the best way to show you what we mean by view state is to show you some examples in our app. I'll see if I can do screen sharing here. Let's see if this works. Share screen, entire screen share. Okay. Yes. I'll make it a little bit bigger so you cannot see yourself. That's probably distracting. So here we have our iOS app. And this is the app we built in a book. It's not very important, but it's a little recordings app, and you can go into folders, create folders. You can go into recordings, play recordings. And there's a lot of view state already. So This done button, when I tap on it, it changes the highlighted to the highlighted state, and it manages that state itself. Likewise, this name I can edit, of course, and the input field or the text field has its own view state. And then if we look at things like a table view controller, if you press edit, the table view goes into editing mode, and this button changes at the top left and back out. And of course, the navigation state is another part of view state. And yeah, I'll stop sharing, I think.
So I think all this state that you've just shown in the app has in common that if you forget about state restoration for a moment, this is all state you would just throw away when your app quits. So this is basically what we mean when we say view state.
Yes.
And all the UIKit components that you just mentioned, so buttons and text fields and even navigation controllers, and split view controllers, table views, they all manage their own view state.
Yes.
And that's kind of how things work in Cocoa MVC, and therefore also in UIKit, is that each component manages its own view state. It's always as local as possible, basically.
Yes, and this works really well if you have individual things. Like if you have a button, then if you press on it, it changes its own internal state. It listens to that. It observes it, and it does everything. And that means that you can just drag a button into your app and it works. And likewise for a scroll view, it manages its own scroll view position. What's more problematic is when you need to share this view state. And as this entire UIKit thing is very object-oriented, this means that either you need to store it somewhere in an object, and if you want to share it among a tree of objects, you need to store it sort of at the rootmost object. So, for example, that would often be a view controller, and then it stores the view state for all the views it manages. When you want to communicate between different view controllers, it gets a little bit more problematic, and the further away sort of your view state is, the harder it gets. So imagine in our little voice notes app that you have a mini player at the bottom, and this mini player would basically continue playing wherever the detail player stopped. So if you dismiss a detail player, it would need to continue playing, just like Spotify or iTunes or any of these things. Now, the question is, how do you communicate changes between the two players?
So suddenly you need, you cannot just have the play view controller, which owns the player and can do its own little feedback loop and to update the state, but you now need access to the state of the player,
yes,
which is view state in our case, from two very different locations.
Yes.
The one is basically the mini player that you would probably insert somewhere into your root view controller to show it always at the bottom. And the other one is nested inside of so the detail player is nested inside of the split view controller, inside of a navigation controller, and then there's a series of maybe folder view controllers, and then the
so we have at the top, we have a root view controller, and then we have a split view controller, then we have the mini player somewhere, and then the other side we have the navigation controller, and then a few levels down there's the play view controller. And to communicate, we would need to somehow bring this view state up to the shared point. The problem is nobody ever does that. And this is because you need to communicate all the changes up and down the tree every time. If something changes, everybody needs to know about it. So the root view controller would send it to the split view controller and so on. And nobody does that in practice.
Maybe you do it across one level or maybe across two. So you could imagine having like a detail, or a master view controller on the left-hand side with a selection, and then you go one level up and communicate the selection down.
Yeah.
Something like this you could still do, but as soon as you have to traverse more levels than that, it gets tedious very quickly.
Yeah, so a not so common solution is something like dependency injection. I think the most common solution for this in MVC, if you want to share view state, is singletons. Which is also what we did to build our mini player. We created a singleton shared player, and then we use it everywhere. And it's a little bit unfortunate, but it works really well. And the communication is just way simpler than having to pass everything down all the layers. And to keep this in mind when you're designing your apps and when you're thinking about sharing view state, I think is really helpful. Another solution that we saw is using coordinators. So a coordinator is often a sort of controller-like object at the top of your tree, and it presents all the view controllers. So it's a perfect way or a perfect place to insert shared view state. So the coordinator would, for example, manage a shared player, and it would also pass that player and all its information.
Coordinator. With the coordinator, it's much easier to inject the shared player into each view controller, is because the coordinator instantiates and presents all the view controllers anyway. So it has direct access to them. And so you don't need to pass it down the tree of view controllers.
Yes.
And we show this in the context of the MVVM implementation in the book. There we use coordinators, but they can be applied to MVC just as well.
Yeah, exactly. The main thing to keep in mind is to think about view state, and especially to think about sharing view states.
But once you have view state defined somewhere, so let's say we build our mini player and we need to put the play state somewhere, let's say in the singleton, where both players have access to it. You also need to think about observation then.
Yes.
And that's something even in Apple's MVC documentation, they call it the observer pattern.
Mm-hmm. Yeah, and they say it's an essential part of model view controller, yet I think not many people think of that when they think about MVC. It's a bit uncommon to hear a lot about observation. And the thing is, if you read a value and from your model or from your view state, and if you present it in your application, then you should also observe it. If you read the documentation about MVC, it's written somewhere on Apple's website, but it's not something I used to think about when doing model view controller. And especially with in the case of this mini player, for example, it sort of makes sense. If you have two different players and they both read the play states, well, because it's a player, it needs to update all the time automatically. So you're almost automatically subscribing to those updates. But for different values, it's also super important. And I think we've all seen this where maybe in a Mac app you have a menu button that should not be gray and it still is gray, or some dialog text that didn't update even though something started loading. There's all these examples where you forget to observe, and therefore your entire application or part of your application comes into this invalid state.
Yeah, so this observation or this consistent observing of the data you are presenting is really important, and not just so with view state we would do that if we have view state that is relevant to two different parts in the app. Both parts should observe some view state value somewhere.
Yes.
But the same applies to model data as well, of course. Yes. And I think that's a bit more obvious still, because there's an example out from Apple in terms of Core Data, for example. So Core Data uses notifications a lot. It always posts these notifications whenever something has changed or will change or did save, or all these kind of notifications. And you are supposed to listen to them and to update your UI accordingly. And so there you have an example in terms of this specific framework, how they envision this to work. But even if you don't use something like Core Data, like in our simple example app from the book, we just have a simple JSON store in the end beneath it. But it works in the same way. It also posts notification whenever something changes. And everywhere we show data, we first fetch the latest value, and then we subscribe to the store and react to changes to these values.
And it's really important that anytime you read data, you subscribe. And so the one of the reasons why it's, I think, often not done in MVC is because there's not one real story. So if you want to observe, for example, navigation controller view state, then you need to implement a navigation controller delegate protocol. if you want to observe core data things, you need to listen to notifications, but maybe you also need to do KVO for certain properties of model instances. And then some APIs take callbacks, other APIs take global notifications. And well, there's any communication mechanism possible in MVC really for communicating these changes. And this is, I think, one reason why we always forget or never really think about observation and why it's so easy to miss.
So the frameworks come with all these different tools, basically, that you can use to observe or to notify others about changes. But when it comes to a specific task like observing global view state or observing the document model or something like that, there is not the one clear mechanism how you're supposed to do it. You have this choice in front of you of all these different techniques, plus others like reactive frameworks and stuff like that. And you need to pick something yourself, and you need to come up with a pattern yourself that you're going to stick to in your app, ideally, and instead of just coming up with ad hoc solutions every time you need it.
Yes. Yeah. So model view controller, I do think it's a great pattern, and I like the implementation in the end that we did. It took us a lot of refactoring, and we needed to establish patterns for sharing view state and for communicating changes and observing changes. But once you have those things down, I think it's a lot nicer. So all this freedom is basically a double-edged sword. On the one hand, you have the freedom to choose whatever you like. On the other hand, you have to pick something, otherwise it will become very messy. And if you forget to observe or forget to share view state, then your application will go out of sync at some point. And there are other architectures, such as the Elm architecture, where both of these things are solved for you by the framework. That doesn't mean that it's better, because you have different problems when you use something like that. So
I think we really saw this when we implemented this example app in many different architectures. And the thing with MVC is, as you said, it has a lot of freedom. And if you want to change something, if you want to add something, implement a little feature here, change a behavior, often it's very straightforward and direct to do it. But this freedom comes with this responsibility to just take care of these issues that we mentioned by, with discipline, basically, and with consistency yourself. And then when you look at the same app in other architectures, then sometimes the architecture does more to enforce doing the right thing. But that also means that doing little things that sometimes seem easy are quite a bit of work to get done.
Yeah.
And that's the trade-off probably between these two poles of the spectrum.
Yeah. So just to reiterate, when you do MVC, think about large view controllers, think about view state, and think about observation. I think that's it for us. We're very happy to take any questions if that's technically possible. Thank you.
So I'm not sure it's over yet, because usually there is a clap at the end. So can we have the clap?
Oh, sure.
Okay, so now we can go with the questions. Does this mic work? We have a funny mic that we have to throw away in the audience. So we will try this mic. Otherwise, I have this one. So questions. Come on. Yep.
Do you hear me?
Yes.
Okay, thank you. In your implementation of MVC, is the controller the view controller or another object? Does the view controller? Does the controller have the role of view controller?
I think almost all controller objects are view controllers. There's the app delegate, which is sort of a controller-like object, but we didn't make any other controllers. And something like a coordinator, which is all hip and new, is really what has existed for a long time already on the Mac, and is another kind of controller object. And I think it seemed to me like having a coordinator can really help clean up your code. I think it made a big difference in MVVMC.
Thank you.
Behind. Lance fort.
Ils sont où? Je vois pas.
This is fun.
Hello.
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 So thank you for the presentation. I have a quick question regarding the implementation of the observer pattern. As you know, there are many libraries doing that for you, like RX Swift or Reactive Cocoa, but it also is possible to implement it yourself. When would you recommend you use a third-party library for that? When would you recommend implementing it oneself?
Well, I think there are many factors there, and some of them might be technical in terms of what works well from a technical perspective, but I think many of them are more social or like depending on the environment you work in. What are you allowed to use? What do your co-workers like, you know, or like what kind of rules do you want to follow there? And I would say, well, for example, some of the reactive frameworks, they are huge frameworks, and they can do a lot of stuff. And the question is like, how much do you need? So sometimes I think if you only need a very small part of it, I would tend to use my own solution probably in this case. If I need quite a lot, well, then it really starts to make sense to depend on a third-party solution. But we also had people who wrote to us that, and multiple people who wrote to us that they can't use something like RX Swift by company policy, basically. And then, well, in this case, you don't have a choice but to rely on what Apple offers you, for example, and to write something on top of that, maybe.
I think if it's just observation, there's a lot that Apple can do for you. So if you have singletons, then something like Notification Center works really well. I know it's not very popular, but you can also, even if you use Notification Center, you can write type-safe wrappers around it. And likewise, something like key value observing now with Swift's key paths, it can be made a lot more type-safe. And if you use things like structs in Swift, they have the struct variables have a dit set, and you can use that or abuse that for observation. I think either way can work. I would say the same thing as you. It depends, but it's something definitely worth thinking about, and a good decision to make with your team and not on your own.
Another question.
Yes. Okay, hello. I have a question about testing. So you talk about different pattern, and I would like to know what is your advice about how to test it?
Yes.
How to test a specific pattern, or just how testing differs between patterns, or what's?
Oh, I'm talking about MVC because you talk about different. Okay.
Yeah. So in MVC, your testing is very integration heavy. So you will. In MVC, it's typical to have a lot of code in your view controller and also logic in your view controller. And even if you can pull some of that logic out into the model, you might also have view state logic in your view controller that you want to test. And to do that, you need to almost always create an instance of that view controller. And there are many people who don't like that. So something like MVVM tries to address that by moving a lot of code out of the view controller into the view model. There are also intermediate patterns where you have something like MVVM, but no reactive programming, which is called model view presenter. And it has sort of the same idea that your view controller only takes values from the presenter and puts them into the views. And that's about it. And then you can test your presenter in isolation. And
I'd say so. If you test MVC, it's hard to be like a testing purist and test MVC. I think you have to be very pragmatic there, and because you are not going to write like real unit tests or something like that. It will always be more, as you said, of an integration test, and you will. Well, but it's interesting. I found this very interesting also to compare different architectures, because with MVC you write these integration style tests, but the tests also test quite some work that's going on under the hood. And when you come to something like the Elm architecture, the tests you write don't test much anymore. In the hopes that the framework is correct and does everything for you. And so I think that's the spectrum there. And in MVC, I think it's as you said, you're testing view controllers a lot, and you have to see how you handle dependencies with that the view controllers have. But yeah, it's always on a higher level than in some of the other architectures.
Another question. No, it's okay? Okay, thank you very much, guys.
thank you.
Thank you.
Thanks for the invitation.